Hi, I'm Chris Williams. I'm the CMO at Arima Data. A couple weeks ago, I did a presentation at the CMA's MarTech Council entitled, What is Synthetic Data? There's a lot of confusion about what it is. There's a lot of mystery, it seems. And so the aim of this video is to capture that presentation and basically expand on it a little bit so that we can get into the marketing applications of what synthetic data is and what we're doing with it at Arima Data. Let me just add the slides here to the stream. There we are. So the intent of this was a briefing for the marketing community and to begin the discussion. And of course, that means any questions and answers can be posed, which we can do on LinkedIn or you can do directly with me. That's chris@arimadata.com if you wanted to send me a private message, or on LinkedIn as well. So let's just jump straight in here and see what we're talking about in terms of synthetic data. At Arima, we're talking about two big things. One is marketing mix modeling, and of course, marketing really understands what marketing mix modeling is. So let's just put that aside for now, and let's look at the other thing that we think is really important in the market right now, which is the use of synthetic data. And that's not really well understood right now. So let's just jump into that. The key takeaways when talking about synthetic data, these are the three. It's national data at an individual level. And we'll explain what that means, but individual obviously means down at the individual person. But when it's synthetic, it means that we're talking about synthetic individuals. The implication of synthetic individuals means that privacy law does not apply to synthetic individuals. They're not real individuals, and therefore you can't gain consent from a synthetic individual. And that is actually a benefit, and we'll see how that works. Because the privacy law doesn't apply, synthetic data is ideal for sharing between parties, whether you're an advertiser or an agency, publisher, broadcaster. The ability to move data sets around, synthetic data sets around between partners, is ideal in the sense that you can have very granular data sets and share those data with each other and use them as a basis for communication about who we want to talk to. Through this presentation, we're going to go through what is it, why use it, how is it made, and what we can use it for as sprinklings throughout the presentation. So let's start here. One of the things that keeps coming up every time we talk about synthetic data, of course, is the word synthetic. And the first part of that is, well, it sounds like it's fake. Synthetic diamonds or synthetic leather comes to mind. And it seems like it's a lesser version of the real thing. We use this analogy of looking at the Sims to help explain why synthetic is not necessarily a problem. First of all, the Sims is a simulation of a game. It allows people to see how a model is working. And in that case, within SimCity, it's you've made a model of a small city. You have all of the activity that you need to do, which is you have to manage a budget, you have to build transportation, you have to build buildings, and the Sims, the little individuals, are bombing around the city, doing their chores, and the model is essentially working. And so, because that model works, and because it has a high correlation to the real population, then outcomes within the model holds statistical relevance to reality. And so it can operate as a way of working through a number of problems and working through a number of options to see what happens if you do this or if you've done that. And because it's a model, you can do these things very quickly. You can do it faster, and you can do it more safely because you're not actually involving real people. Synthetic data has been around a long time. The term, like, we're not going to rebrand what synthetic data and come up with a new word for it. It's been around since about 1987 in bioscience, and they have a set of terms. And when they're doing various experiments, is they can do it in vivo, they can do it in vitro, or they can do it in situ, like in place, or they can do it in silico. And that means they're going to build a model. They're going to use the computers to understand the population and what the impact is of certain activities within that model, to understand what's going to happen, when you introduce a vaccine or when a virus is introduced into a population. These things are much better done, obviously, in a computer model than they are done in situ in real life. So in a way, what's happening is that bioscience has been around doing synthetic data and modeling for a lot longer than marketing has. And so marketing is in a way a little bit behind the curve in its use of synthetic data. And so we can see analogies of where it's going by looking into the medical field and, and see what they're doing with it. Well, Canada is actually a leader in this area. So if we look at a company like Replica Analytics up at the Children's Hospital of Eastern Ontario, um, in the medical field, they're using synthetic data at a very high level, and of course, they're publishing the results and writing books about it and telling us what's going on with the kinds of things that they're doing with synthetic data. And that's really exciting because the analogies are there for us to use it in marketing. Over here on the right is what we're doing with it at Arima Data. So in this case, in business and marketing analytics, Winston, founder of Arima, has this academic white paper. It's peer reviewed and published that explains how the synthetic data is actually being synthesized from aggregated data sets. So panel data, survey data can be downscaled into synthetic individuals. If you're interested in getting that white paper, just let me know. It's public. We pass it around all the time. And of course, it's pretty heavy reading. It is an academic white paper with a lot of machine learning and computer science in there. So let's just start to think about the implications now of what synthetic data means from a marketing perspective. In marketing over the last 20 years or so, the activity around privacy and privacy consent management is a very hot topic. And so we've looked into the privacy regulators to understand, what are the rules and conditions that have to be met in marketing in order to use the data that we need, whether it's CRM data, email lists, cookies, other identifiers within programmatic media. And one of the leaders in the area of privacy has obviously been Anne Cavoukian, who is the former privacy commissioner of Ontario. And many, many years ago, she came up with the concept of privacy by design, which included all the principles around how does any company build out their practice using privacy built right into the very initial steps as they build out their data and their data management structures. Well, when we looked into some work that was being done at IAP, and the article is linked there, is she comes up with this quote, is that synthetic data doesn't present any of the risks associated with real data, which has personal identifiers linked to it. And in her view, it's going to be the future in terms of privacy and data utility. So this is a really important quote because it's not just about the privacy aspect, it's about the data utility aspect of the use of data. And that goes back to what I was saying in the first place, which is about the sharing of data sets between partners, which is done a lot in marketing between publishers, broadcasters, advertisers, and agencies. So this data utility aspect in respect to privacy is a critical understanding of around why we want to use synthetic data. And it looks like this. You may have an outstanding database of all your customers, first-party data, and it may have an enormous amount of granularity about each of the millions and millions of customers in your database. And that would put you in the far upper left-hand quadrant there. You have a high amount of granularity, a lot of users. In your mind, you've got a lot of data which you can access. But in order to use that data on the data utility scale, you actually have to start losing some of that data in order to make it functional from a privacy perspective. And that's the curve. And as you lose certain parts of that data, the utility, the ability to use it and share it, for instance, actually goes up, but the amount of data within it goes down. So of course, you're de-identifying the data. You're removing names and email addresses and phone numbers and cell phone numbers and all sorts of things in your database in order to make it usable. Now, synthetic data doesn't have that problem. The data that's in there has been made up. It's a work of fiction, which we'll talk about, and that means that because the data privacy laws don't apply, is that you can use that database without any de-identification or generalization. Now, of course, it's not going to contain, an email address in it, but it is the support for the model at the national level. Here's the privacy angle. So again, going back to Khalid and replica analytics, he wrote a book about the uses and generation of synthetic data. And so I just grabbed a couple points here. One is from the website of, who's he working with in terms of privacy commissioners and regulators and lawyers. You can see Liz Denham there, who is the former privacy commissioner of the UK, and she was before that she was the BC's privacy commissioner. And so they have a webinar talking about the future of data sharing using synthetic data. Over on the right, of course, you have Adam Kardash over at Osler, talking about the identifiability of Bill C-27, and again, sort of the aspect of how synthetic data applies there. And then the quote from the page is just looking into privacy law, in this case GDPR, and asking the question, does GDPR apply to synthetic data? And the answer is no, it doesn't. It's not about the synthetic data is not about a person. And so that's where you get into this point that when people say, oh, the synthetic data sounds fake, it's actually, that's a good thing, because it's not about real people. And when it's not about real people, then the law does not apply to it. And so that's actually a benefit. So let's talk a little bit about data downscaling. How is this data created? And downscaling is taking, let's say, panel data or survey data, data where you have a sample, and then how do you create that process that takes that sample data and then turns it into individuals so that it matches what's happening at a national level. So imagine what we're going to go through here is just a simplified version. But what we're going to do is we're going to start with this database, and just think of it as an Excel spreadsheet for now. What we're going to do is have 38 million rows. There is a row to match the number of people in the population of Canada. So we have 38 million rows, and then we have as many columns as you want to have. So we have started with about 5,000 variables within the database. That's going to be moving up to about 25,000 shortly. But we had, in this case, let's say there's 5,000 columns within this spreadsheet. And the place that we're going to start is the first column, which is just, we're going to apply an ID to every single one of those synthetic individuals. So they're all unique. And then the next point, next column, is we're going to apply what is the postal code of that synthetic individual. So in this case, what we're doing is we're going to access the Census of Canada, which explains how many postal codes there are in Canada and how many people are within each postal code. So with 825,000 postal codes, we have to assign a variable out of one of those 825,000 against each of those synthetic individuals based on the number within each postal code. That is obviously public information. It's not PII. We've accessed nobody's sort of proprietary database here to do this. And basically that informs the first column to say, look, here's how the population spills out across the country by assigning those synthetic individuals into each of their locations by postal code. It gets a lot more complicated from here on in because we're going to start to access multiple data sets at the same time. And this is where the artificial intelligence and the machine learning come into play, because we're dealing with a lot of data to analyze and then assign attributes to each one of those columns throughout the spreadsheet. So what it's doing is it starts with the left hand and it moves over to the right, and it starts to assign variables sequentially from left to right through what's called conditional probability. And what it's doing is it's looking into these other databases and saying, well, if we're trying to figure out if this synthetic individual should have a pet or not, let's look at a whole bunch of different variables that might be indicators of whether they have pets or not, where they live, what car they drive, how they've answered certain questions, maybe around pet food or other things. And of course, that leads us to say, well, if we have to have a number of pet owners, we have to assign them against each of these individuals. And that gets done in the database, and that creates the data against each of the individuals within this whole synthetic population. at the end of the process, of course, you have 38 million individuals with all these variables attached to each one of them. And so that has it's important that correlation is preserved throughout the process, so that when we look at A versus B, is that that correlation continues to exist. We can add in additional data sets. So if you have some first party data and you wanted to bring it in, that is possible as well. It does change the nature of the database depending on what type of first party data is being brought in. But if there is some specific, um, in this case, for instance, brand use that's not in the database in the first place, but as an advertiser you wanted to bring it in, that is absolutely possible to do. So what are the functional benefits? Obviously, we've talked about the sharing of this data. This data can be passed and shared between multiple groups, advertisers, agencies, publishers, broadcasters can all be looking at the same database and understanding the same consumers based on this probable synthetic database. We can map the synthetic database with other databases. Obviously, the synthetic individuals have all of their media habits attached to each of their individuals. So what that means is that we can query the database in terms of looking at certain attributes and say we want to target certain people, and then be able to understand sort of how their media works, and that starts to uncover these correlations between these variables. So what that means is that that's what the database kind of looks like, but we build tools on top of that. So you query the database and say, look, what I'm interested in is people who have pets who are in certain regions, whether it's postal code or cities, that use certain brands, or maybe they consume a lot of TV, or whatever variable is in the synthetic population can be queried. And so in this case, you can say, well, tell me about these type of people. You define them, and it gives you a count. In this case, about 2.5 million synthetic individuals are pulled out of the database. And then you can look at them and say, well, what I'm interested in is seeing their restaurant visits. And you can see them by index and sort of uncover insights about them. Well, if that's your target group, then you can also create a campaign based on reach and frequency, media costs, channel usage. All of that just becomes available to be built on top of the synthetic population. And so this is a tool that we have, which is a campaign reach and frequency planner. And so we put in our costs, we put in our targeted media, and it takes the synthetic population and says, okay, well, based on their media habits, this is how that campaign is going to build. And depending on how much money you're spending, which is the slider, you can decide what is the optimal budget that you would use against the target group within the synthetic population. Now, because the synthetic population is not specific to any one media, it is perfect for cross-media planning. So we can use it from everything from TV, radio, out of home, digital, social, search, direct mail. All of those things become part of the sort of the media habits that are placed within the synthetic population. And that means that it's an ideal tool for agencies to use. Once that's done, what we're looking at is, and because we're a startup, we're building new tools as we go along, is how do we describe that population and then share that data with the next step in the process, which is an area where we're building this, is to say, okay, well, we've got these synthetic IDs that we've identified within the target group. We know them. And through the campaign planner, we've identified how much money should be spent against each of these channels, each of these different types of media formats, even in some cases, right down to the media provider. And we can share that data and pass it along to say, these are the synthetic individuals that we want to target based on these amounts of dollars being spent in these regions against these type of media. And that's going to be a very powerful sort of approach to passing that data along to the next step in the process of media planning. We can also add in additional business data that comes in to that's available for the synthetic population. So in this case, we can bring in mobility data, and that allows us to see patterns of where people are moving around the various cities and look at it from the synthetic individual perspective and say, okay, well, if we have these mobility patterns And if we know the synthetic individuals' postal codes where they live and how many of them are there, we can start to see sort of uses for mapping and say, okay, well, here's locations. We know store locations. We know other points of interest locations. We know out of home locations. All of that can be brought together into a mapping area. So in this case, what we're doing is highlighting people who have pets and identify them as a target group and then want to bring in the mobility data. It starts to look like this. And this is where we've mapped them out. We can see them as they index. So red is a high index, blue is a low index. So that's the target group mapped out, counting the number of synthetic individuals within each postal code. And of course, we can ladder that up to FSA or CMA or city or province or whatever you want. But it starts off with, at the very lowest level, synthetic individuals mapped out into the postal codes at an index level so that we can identify those hotspots and say, these are the areas that we want to target for that particular group. And that allows us to say, well, what about out of home? What about looking at search and social by FSA? What about terrestrial radio stations that cover these areas? It leads us into an area which really helps us focus cross media, both digital and analog, on the same basis. That's when we add in the mobility data, that's what it looks like. We can see numbers going in and out of each of the postal codes so that we can understand the volume of movement that's happening. Now, remember that we started this thing with looking at a national synthetic population. That's 38 million rows within the whole country, which matches back to the census number. This is important because what it means is that this national synthetic population is at the top level, and any first-party data set that applies to Canada sits within the synthetic national population. What that means is, if you look at on the right-hand side, you've got the big circle, which is the national synthetic population. Any first-party data set that you bring in to compare, to match, to put into as an index against that population, you're going to get a very, very high match rate, because all first-party data sets are a subset of the national population. And that's different than when you look at, let's say, a clean room where you have even the largest media providers and the largest advertisers. You put the two data sets together, they do not have everybody within the national population, obviously. So there you have the intersection where you have both of these large parties coming together to say, well, sure, their numbers are large, but you have to only look at the intersection of those two data sets to be able to match and manage consent and move forward with. Advertisers and marketers might want to also bring in their own first-party data and look at synthetic data in relation to their own first-party data. And again, this changes the nature of the database, but it can be extremely valuable for a marketer that wants to learn more about the type of people that they have within their first-party data, and of course extend their data into the national synthetic population. So what they can do is they can give us some variables. We can do a match on our within our database, and then pass synthetic individuals back and variables back to them. Because remember, our synthetic database is all about sharing, so we can pass that data back. And then, of course, on the other side is they have a much more fulsome database of discovery of variables against the types of people that they have within their own first-party database. And of course, that has to sit on their side. The other thing to think about from a media perspective and media buying is how potentially these synthetic individuals can sit in between the buyer and the seller and operate as almost like a shared identifier between the two of them. So in this case, imagine you have an advertiser on the left side accessing the synthetic data set. They have access to all the synthetic IDs and all the variables that they need to use for planning. On the right-hand side, you have a publisher or a broadcaster that has access to the same data set, the same synthetic IDs, same variables. As the advertiser passes the data from their side over to the other side, is that all they have to do is pass the synthetic IDs and any of the cross-media campaign description. So how many impressions or how much media weight or how many dollars per channel per whatever goes over to the other side to be activated and used in terms of the media planning side. And that operates at a cross media level, right? Because it's not specific to digital. You could be, as an advertiser, you could be passing these synthetic IDs over to the sell side with the intent of using that, let's say, for even terrestrial radio, to say these are the postal codes which we want to target. And of course, postal codes means you have footprint from the radio stations, local radio stations. Could be local media, could be local newspaper, magazines, whatever. There's enough data being passed between the left and right as a shared view of the national population to say, this is the media that we need across all media. Now, that's moving from left to right. Once the campaign has run, then you can also apply how much actual media weight was applied to each of those synthetic individuals and pass it backwards in the opposite direction and understand campaign delivery and deduplicate that against the synthetic individuals, which makes it a nice database to start using for things like marketing mix modeling and bringing it back into comparison with the advertiser's first-party CRM data sales. What that means is when we look at the current setup, and there's some critics of the current setup, Johnny Ryan is in Europe, focuses a lot on the bid request and its problems with GDPR and how much data is in the bid request. What this approach of using synthetic data does is it minimizes the data in the bid request, meaning instead of broadcasting, tons and tons of data about individuals in the bid request for digital programmatic media buying, what it does is it just reduces that down to a synthetic ID. And that would be a huge step forward in terms of privacy compliance. On the other side, you've got Dr. Fu explaining, just how much pixel firing that's happening with, based on all of these sort of pixels that are being placed within pixels within other tags, and how much sort of data is being just broadcast all around, and all these providers that are sort of piggybacking along with other pixels as they fire out there, and it's causing quite a lot of it causes a lot of computer power for one thing, which is driving a lot of carbon emissions. But it's also just a mess in the sense of like, who are you really sending data to? Very hard to manage consent in this format because you really have no idea where the data is going. But again, by minimizing the data in the bid request and making it based on synthetic data, it eliminates that problem in the sense that you're not sharing as much data and you're not sharing real data in that format. The other thing we can do is to sort of realign the columns and say, okay, well, let's understand things a little bit differently here. Let's look at it from a marketer perspective, where they may have a sales territory or they want to do an A/B test of this geography against another geography. Let's say, like Barrie versus London or Halifax versus Calgary, for instance. These things can be organized by geography and say, okay, these are our territories that we want to look at, and reorganize the synthetic database, synthetic population to say, well, okay, within those territories, we have these postal codes, therefore we have these synthetic IDs. We can look at it from actual sales, from the store sales within that geography. And then we can also start to bring in things like paid search results by FSA and map those out. So we can start to layer in by geography a lot of data to help understand what's happening in terms of media, in terms of search intent, in terms of sales, relative to things that are absolutely critical for marketers, things like, same store sales or sales territories that they need to manage. Those can also be used for creative testing. Let's isolate a geography, do something different, test headline A versus headline B. And of course, that also brings in, let's look at the actual sales per store locations. When you add in the mobility data, it really helps to understand, where people are visiting and moving and where they're coming from in terms of this geography. And so let's have a look at a sample of that. In this case, Coke brought in Arima to bring in the synthetic data database with mobility data. And Winston was looking at 26,000 Coke vending machines across the country with the synthetic population and the mobility data. And the intent is to optimize where the uh, locations of these vending machines should be to get the most sales based on the types of people that are purchasers of Coke. Here's what the search analysis looks like. We've brought in some data from a search account and mapped it out by FSA and indexed to show these are the areas where we're seeing a large amount of response in terms of search. Obviously, that's been based by consumer interest, often generated by broadcast media. And then you look at, of course, the retail outlets, so we can understand, which areas are likely to get the most sales. Now we know that share of search is a leading indicator for brand. Academics have identified this as a really important metric to be looking at. It bridges upper funnel versus lower funnel media tactics. So it's critical that we start looking at search from a geographic perspective so that we can align it with other things like um, analog media and retail sales. And notice that we're not using identifiers or multi-touch attribution or any type of sort of one-to-one identifier in this. This is far more advanced than that. So I think that brings up the biggest question, which is, in marketing right now, there's a huge amount of attention being paid to identity and pixels and attribution, and it's almost taking up too much of the attention, because really what we should be looking at is geography, synthetic data, and marketing mix modeling as the way to view what's happening in our marketing efforts. Now, a lot of people might say, digital is heavily focused on let's say identity and attribution. And you say, well, but actually Facebook and Google are spending an enormous amount pushing marketing mix modeling into the market. So they're obviously seeing the writing on the wall in terms of identity and privacy problems. So if they're going into MMM, we really all should be heading towards MMM. And if we can do it through geography and synthetic data, it really does create a much better playing field for marketers, broadcasters, agencies, and publishers. Which comes to this. We've seen the challenges of local media in Canada and some of the problems that they've been running into, and it's come up at the Canadian Media Directors Council, where they've issued this Canadian Media Manifesto for support for local media. Well, in order to do that, we need to improve how local media can be planned, which means we need more local data for media planning. And that is one of the things that is really strong in using a synthetic national population, as we can look at every single postal code across the country based on the synthetic individuals within the population, knowing also their media habits are attached to it and their purchase habits are attached to those synthetic individuals. So we can look at local areas, in this case, Cape Breton, for a target group, and hopefully that helps to support local media. And of course, it has to bear out in terms of effectiveness, looking at marketing mix modeling. But if that's the case, potentially this is a very strong direction for local media. It has to be actionable. So not only do we have to be able to see it on a map, but we have to plan it and make those plans and allocate those dollars within a planning tool, so that the advertiser and the agency can look and say, okay, this is what we're doing, and this is the reach and frequency, the effectiveness, the efficiencies that need to be there. All of that has to be built into the media planning structure in order to achieve what they're trying to do. So hopefully that's enough for now. In conclusion, obviously, we've got synthetic data is a major innovation for marketing. It really is the basis for data sharing, based on the fact that privacy law doesn't apply to pure synthetic data. It gives you that individual level data, so we can look at people per postal code, but synthetic people. It has that high degree of utility. It can be shared, it can be used, manipulated in many different ways. You can add synthetic data to first-party data and uncover other insights. It ties in very well across international, national, and local. There are other data sets, other synthetic data sets. We've also done this in the United States. We know that they're building this in the UK as well to look at cross-media measurement is what they're using it for there. And of course, it has a high degree of privacy compliance. So if you have any questions, be happy to answer them. Shoot me an email at chris@arimadata.com. Make a comment on LinkedIn. Here, I can answer it there. Or through a DM me on LinkedIn. That's probably a very good way of reaching me as well. So, and lastly, just this point is, if you're interested in investing in synthetic data, obviously, we would love to hear from you. We have starter ways of doing that. We offer tools so that you can use the synthetic data right off the bat. There's more advanced ways to start looking at it and manipulating the data. And then at the very highest level, we can make the data available to you through an API for your data science team. On that point, thank you very much for spending some time with me. And if you have any questions, happy to answer.